Good night, everyone. Mechanics of Materials, Chapter 5, Torsion. Let's solve an interesting example in 10-volt hollow shaft. So, in this example, we do have a cross section which is hollowed one, and a 90 Newton meters torsional torque is applied to a hollow shaft having a cross section shown. We want to determine the shearing stress at point A, which stands in a part which the thickness is 4 millimeters, and also tau b. If you remember, for such problem, the very first thing we need to do, tau is equal to T over 2am times T. And if you need to go for here, T at A is 4 millimeters. And for here, you need to consider a thickness of B, which is 2 millimeters. Let's approach our problem. So in such problem, we want to calculate tau at A and tau at B. Tau at A and tau at B to see how we can calculate this value. So the very first step in doing so is just if you consider the center line, we want to calculate AM. And AM is just AM, which is the center line. If you consider the dashed line for the center line and connect them together, it seems we do have a big square, which consists of thickness of here is 2 millimeters. So if we just subtract the half of that, which is 1 millimeter from one side, and the thickness of this part is 4 millimeters, and we just need to subtract a 2 millimeters from here. So that turns 55 minus 2 minus 1. It just gives us a 52. So 55 minus 2 minus 1, it just gives us 52 millimeters. So the big square is 52 millimeters by 52 millimeters in dimension. And if you look at the configuration, if we just extend these two again to the center line, this is radius, again this is 39, and if we just subtract this part, a smaller square by 39 by 39, and then add this part, we want to then add this part to have our shape. So we are just removing that small left area, this reddish dashed area, we are removing this part. So this is plus a quarter of pi r to the r squared, and the radius is 39 because the center line stands here and we need this part. And if we just add this up together, we will have our area M, then the rest is replacement in the formula. So let's see how we can approach our problem. So let's make it a bit clean. So we are looking for AM. So this is our biggest square by 52 by 52 times 52 minus a smaller one, 39 by 39, plus a quarter of circle, which is by radius of 39. This is plus, this is minus, and it finally gives us our original shape. And then if you do the mass, AM is equal to 52 squared minus 39 squared plus a quarter of pi 39 squared, all in bracket, conversion of millimeter to meter, and that's 10 to negative 6 meters squared. And if you do the math, it just gives you 2377.59 times 10 to negative 6 meters squared. And as soon as we have AM, you can just jump to the main equation, but don't forget for A, use thickness of 4 millimeters and 4b thickness of 2 millimeters. That's essential. So if you do so for tau A, you can get a 90 Newton meters torsional torque times 2 times AM replacement and the thickness of A, and it just gives you tau A is equal to 4.37 megapascal. Do the same for a B, tau at B, everything remains the same, but the thickness goes by half. Definitely tau B is higher than tau A. So that's tau B is equal to 9.46 megapascal. And that's all we had for this example. We'll solve more problem. Thank you.